All right, we're back with Chapter 10, Flow and Conduits, and we are going to cover Chapter or Section 7 in this particular video. We're going to look at solving flows problems with turbulence and when we can't use equations with analytical solutions. So we need to have a strategy for doing these problems. And so we're going to work these problems, some of these problems in class, but what I'm going to do here is just lay out a quick strategy for doing these types of problems. And that's what this section is all about. So flow and conduits is difficult. We know that because it's a very complex, chaotic flow, and a lot of times we cannot solve these problems with equations in algebra like we can for laminar flow. and thus engineers need to have a strategy for solving problems such as these that involve turbulence. And so the first thing that we traditionally need to do, you should know this by now, is to look at the Reynolds number, calculate the Reynolds number for using the appropriate dimensions for the problem, and determine if it's laminar or turbulent. Then if we determine it's a laminar problem, we're in good shape. We can solve the problem using the equations that we have already derived early in this chapter. If we are lucky enough to have a computer, a fast computer with the right software, and we know how to use the software, we can do what's called computational fluid dynamics, or CFD, and we can use these programs to solve the problems for us. That takes a lot of expertise and a lot of time to learn. So that is not something we're going to do here. So instead, we're going to rely on their traditional approach, which is to classify the problem into a couple of different cases, case 1, 2, and 3, and apply the methods without a computer. So let's just take a quick look at the three cases of the traditional approach. Case 1 is when the goal is to find the head loss, but you were given the pipe length, the diameter, and the flow rate Q. This problem is straightforward, and it can be used through a combination of the equations that we've already derived and also through use of the Moody diagram. Case 2, on the other hand, is when you want the flow rate and you're given the head loss, the pipe length, and the pipe diameter. This problem usually necessitates using what's called an iterative approach, where we have to do a calculation and check our answer and then do another calculation. Usually it takes a couple of iterations, 2 or 3 iterations, to basically converge onto a solution. But we'll do a problem. I think it's example 10.4 that we'll do in class on this. And then case 3 is when you want to find the pipe diameter. This might be a situation where your pipe is inaccessible. It might be underneath a street, or otherwise you can't get to it, buried under something. And but you're able to measure the flow rate, and you know the length of it, maybe from a drawing or something. And then you don't know, or you do know the head loss. This can also be done using an iterative approach, and this is described in example 10.6. So there's 4 examples here that in the book that we can rely on, and we'll do some of these in class. So there are some exceptions. For instance, in certain situations, we can rely on this equation where we are able to use the top scale of the Moody diagram, which gives us the Reynolds number Reynolds number times the square root of the friction factor. And remember, that's just that top scale is really just the Darcy-Weisbach formula, or a formulation of that. And so we can rely on that and use this equation for Q. And also there's, in some cases, we can use this equation for getting at the diameter. Now these are not the book does not really lay out when you can and cannot use these equations. And so it does give you the the option to go and read the papers that tell you how to do this. And one of the papers is actually by uh, Swami and Jain, and another paper by Streeter and Wiley. So in order, this is kind of an advanced topic, which is beyond the topic, basically beyond the scope of this book and this course. All right, but we will work some of these examples to primarily show you this iterative approach, and we'll work some of these, a combination of these 4 examples, and do these in class. Okay, thank you.